Today's topic is all about Cholesky Method. And Cholesky Method is a decomposition of Hermitian positive definite matrix into the product of lower triangular matrix and its conjugate transpose, which is useful for efficient numerical solution. So, as a definition said that Cholesky method is the product of a lower triangular matrix times its transpose. So this is an example of a matrix. This is a lower triangular matrix and this is a subtranspose matrix. So what is the Hermitian means? Hermitian means is when you transpose your matrix, it is the same as your matrix transpose is same as your original matrix. That's the Hermitian. So getting this kind of equation here is by multiplying the row matrix to the column matrix. So example is when you times A is A squared, then 0 times B is 0, so 0 times C is 0, so it just becomes A squared. That process is same to come up to this equation. So we have A squared, AB, B squared plus C squared, BD plus CE, AD, BD plus CE, and D squared plus E squared plus F squared. We can use it to solve for the value of the A, B, C, and D, E, F. So let's have an example. So this is the example of This is my example. This is our matrix, the 4, 10, 8, 10, 26, 26, 8, 26, 61. Our first step is we need to find its transpose. So its transpose is, we will make the column as a row. So 4, 10, 8 will become our first column, 4, 10, 8. Then our second column, 10, 26, 26, and our last column is 8, 26, 61. So as we can see, the lower triangular matrix and the transpose matrix is the same to each other. So we can say that this is a Hermitian. So our next step is putting here the matrix, and we can now solve for the value of A, B, C, D, up to F using this equation. So let's try it. So first we will get the value for the A. So as we can see here that the A squared is equals to the value of 4. So A squared is equals to 4. So we square root of A squared on 4. A is equals to 2. So now we have a value for A, and it's 2. So let's now find the value of AB. So AB is equals to 10. So AB is equals to 10. So we have a value of A which is 2. B is equals to 10. So divided by the 2, our B is equals to 5. So in getting for the value of C, we have B squared plus C squared is equals to 26. So B squared plus C squared is equals to 26. So since we have a value for the B, which is 5, so 5 squared plus C squared is equals to 26. And the 5 squared is 25, so C squared is equals to 26 minus 25 is equals to 1. Then get the square root of 1 and it equal to 1. So we have a value of C equals to 1. So let's now find for the value of D. So we have here the AD is equals to 8. Since we have value of A which is 2, 2D is equals to 8. So divided by 2, we have a value of D equals to 4. So for the value of E, we can use this. Use once BD plus CE is equals to 26. So since we have value of B, D, and C, let's substitute the value. So 5 times 4 plus 1E is equals to 26. So 5 times 4 is 20. Since 1 times E is just E, is equals to 26 minus 20. So the value of our E is equals to 6. So last is for getting the value of F. So we have D squared plus E squared plus F squared is equals to 21. So D squared plus E squared plus F squared. Since we have value for D and E, we will just substitute the value that we solved earlier. So the value of force is equals to 16 plus 6 times 6 squared is equals to 36 plus F squared is equals to 61. So F squared is equals to 36 plus 16 is 52. So 61 minus 52 is equals to 61 minus 52 is equals to 9. So since we need to square it, to get the square root of 9 is equals to 3. So the value of RF, I can just put it right here, is equals to 3. So since we have the value of all the variable A, B, C, D, E, F, let's put it here in the matrix. So let's substitute the given the value for A, B, C, D, E, F to this matrix, to the lower triangular matrix. So A is equals to 2, equals to 2, 0, 0, 0 here, and the value of RB is 5, the value of RC is 4, then the value of RD is equals to 4, then the value of, oh my god, the value of RC is 1. The value of RE is 6 and the value of RF is equals to 3. So we need to get the transpose of this matrix. So as I said earlier, that we just need to change the row as a column and column as a row. So 2, 5, 4, then 0, 1, 6, and 4, 6, 3. Mali. So I'm so sorry. So we need to change this column as a row. So it should be 0, 0, 3. So as we can see that we get an upper triangular matrix. When we solve for a lower triangular matrix, we can have a value of upper triangular matrix. So it means our answer is correct. So that's all for today.